Dear students, we are on the CEC Gurukul lecture, and today we will discuss the new series, that is a quantum technology. In the quantum technology, which is nowadays is a very important technology and are used for the various purposes, and how the research is growing or going on in this quantum technology, we will discuss the various development in the quantum technology. So, the quantum technology aims is to develop the quantum computing, quantum communication and the sensing over the next generation. For the initiative is expected to boost the research in the areas such as secure quantum communication, cryptography, advancement in the material discovery. So, the quantum technology we will discuss for the various transformation in the field of drug delivery, climate modeling, logistic optimization and artificial intelligence. So, however, there are many challenges regarding the quantum technology, which is highly unstable and prone to error, require the near zero temperature and advanced error correction techniques, but still there are a various initiatives taken by the National Quantum Mission that has outlined the specific objective to the advanced Indian capability in the quantum regime, in which first is the quantum computing evaluation. So, quantum computing evolution means develop the intermediate scale quantum computer that must be of 20 to 50 physical qubits and 50 to 100 physical qubit in the next 5 years and 50 to 1000 physical qubits across the platform like superconducting and photonic technology to advance the computational capabilities. Means we are talking about the quantum technology where we use the quantum. That quantum which totally related to the photon and related to the size of the atomic and molecular. So, the various initiative has been taken for development of the quantum computing. Next is the satellite based quantum communication that established the satellite which enables a quantum secured communication between the two ground stations over the 2000 kilometer within the nation and extend this technology for a long distance for the secure quantum communication with other countries also. Another initiative is the intercity quantum key distribution, like implement quantum secured communication spanning 2000 kilometer using the trusted node and the wavelength division multiplexing WDM on existing optical fiber infrastructure for enhancing the secure data transmission. Now, multiple mode quantum networks are required in this field. So, develop a multi-node quantum network incorporating quantum memories, entanglement, swapping and synchronized quantum repeaters at each node that enable the scalable and robust quantum communication. Another is the advanced quantum sensing and clocks. Up to now we are having a nano sensors of the size of the nano. Now the sensitivity should increase, so quantum sensing and clocks are required. So design highly sensitive quantum devices including magnetometer within the 1 femtotesla square per square. Sensitivity is in the atomic systems and better than the 1 picotesla per square root. In the nitrogen we can see centers. So, gravity sensors with better than 100 nanometer sensitivity and atomic clocks with the 10 to power minus 19 fractional instability for precision timing, navigation and the secure communication. Another is the quantum material and devices. That is another initiative Up to now we discussed about the nanomaterials and nano devices. Now the demand of the time and demand of the generation is the quantum material and devices. So develop and synthesize next generation quantum materials such as superconductors, novel semiconductor structures and topological material for the fabrication of qubit, single photon sources, detectors, entangled photon sources and the quantum sensing metallurgical devices for application in the quantum computing and the communication. So the National Quantum Mission, that is one of the important mission, and that mission just aim at the just get it at the global level, and this will help through the this mission will be completed through the quantum technology. Right. Now the advancement in the secure quantum communication, quantum computing and precision sensing, the mission is poised to transform the sectors such as telecommunication, defense, finance and healthcare, just delivering a profound social impact. So this quantum technology are used in the various field for its advancement. So there are the various limitations of the classical technology, that's why quantum technology came into the account. So what are the limitations of the classical technology? Classical computer, classical sensor and the communication system are reaching their physical need, like complex problems like simulating molecules, climate system or optimizing global logistic can take millions of years even as a supercomputer. Another point that we use the quantum technology is required. What is the power, exponential power of the quantum is that quantum system can process information in the parallel. That is because of the two important point, one is the superposition and another is the entanglement. So this make them capable just solve the problem in the seconds or the minutes that classically system cannot do. So the two important feature of the quantum system is the superposition and the entanglement. Because of that, the process is the system works speedily as compared to the classical system. National security and the other purpose is the quantum cryptography, that is easily done through the quantum, and there are the another strategies that we can do through the different type of the quantum methods. Right. Now, what is the difference between the classical and the quantum mechanics? First, we will discuss the basics of the classical mechanics and the quantum mechanics, then we will go into the quantum technology, then we discuss the why this technology is important and what is the requirement for this technology. So, first is the classical mechanics, then it deals with the macroscopic particles, but here in the quantum we use the microscopic particles. Moreover, it is the classical mechanics is based upon the Newton's law of the motion and the Maxwell electromagnetic wave theory. Any amount of energy may be emitted or absorbed continuously, that is explained in the classical mechanics. That is not defined by the discrete values, that is a continuously absorbed and the emit of the energy. So the state of the system is defined exactly by the specifying their positions and the velocities. The future state can be predicted with certainty, but in case of the quantum mechanics, it deals with the microscopic particles. It based on the Schrodinger equation. Moreover, in the Planck's postulates only the discrete value of the energy, that we will all know that discrete energy is emitted or absorbed, that explain the origin of the quantum, that is the quanta with the packet of the energy. That packet of energy we will use further for the development of the development of the material, of the devices, moreover of the sensors and etc. So, quantum mechanics, because of the Heisenberg uncertainty principle and de Broglie hypothesis, dual nature of matter. So, the state of the system cannot be specified exactly, that we define by the quantum mechanics. It gives the probabilities of the finding the particle at the various location in the space. There we define the, there is a certainty, but here the probability of finding the particle in the various location in the space. So, there is a difference between the quantum and quantum as well as in the you can say quantum and the classical theory. So, now on the quantum computer program, now here we use the quantum computing. In the quantum computing, we use a quantum computer that programs executed through the unitary evaluation of the input and the output state. There we define the state by using the 0 and 1. There we use the binary condition in the classical regime, but here in the quantum technology, just this 0 and 1 change with the qubits. So, now how quantum technology works? Just to understand the quantum computing, it is important to understand the 4 key quantum mechanics principle. So, whenever we talk about the quantum technology, these 4 quantum mechanics principles are required. First is the superposition. That is a very important point, that how the quantum technology work. This quantum technology work on the quantum mechanics principle, that are: number 1 is the superposition, next is the entanglement, third is the decoherence, and fourth is the interference. These 4 are the main point for the quantum technology that we will use in the quantum computing, we use in the quantum material definition, we use for the sensing purposes, communication purposes, we use these superposition, entanglement, decoherence and the interference. Now first we discuss the quantum bit, that is the qubit. In the classical regime, we use 0 and 1, 0 for the off, 1 for the on. But there we use the binary system, binary bit, that is the bit. Now we use the qubit. Bits are 0 and 1, but here we use the quantum bit, that is the smallest unit of the information in the quantum computer, that is the qubit. It represents the state of the wave function, that is represented by this symbol, that is a psi in the Schrodinger equation, that representation of the wave function. So, a qubit may be in the on state or in the off state. If it is in on state, that is 1, if it is in the off state, that is the 0. Many ways to implement a qubit: nuclear spin in the NMR, that represent the 0 and 1. That represent the nuclear spin in the NMR, that is the qubit. For the photon in the cavity, it is used the 0 photon, that is represented by the 0 and the 1. It is very easy, phi is equal to 0 and 1. In the photon state, it is represented by 0 and 1. 0 photon 0, 1 photon 1. If we talk about the energy state, that is represented by the Gs, and it is represented by the 0 and excited state 1. Gs means ground state, it is 0, and excited state it is 1 when we discuss about the energy state. There are the another like polarization of the photon, many others, then we use these symbols or these qubit in this form. Now the qubit, it is a fundamental unit of the quantum computing, is the qubit which can be 0 or 1 both at the same time, that is a superposition. Superpositions allow a quantum computer to explore many possibilities simultaneously rather than one at a time. This is the superposition. First we discuss the qubit, that we define by the 0 and 1, that is a qubit. Now another is the superposition. What is this superposition? This superposition means we are having a 0 and 1 or the both, there is a condition. So, if there is a both means the quantum computer allows many possibility simultaneously rather than one at a time. That we can explain that if you take a coin that it is having a head and it is having a tail. When it is it is in your hand, then we can see the one part, that is the head. Now we throw in the sky, then there is a possibility of the 1 0 1 0 0 1 1 0. Again when it drop at the surface, then we again get the one probability, that is either the head or it is the tail. So, we are having the various probability of, now we have three condition. Now, one is the first, it is on state, next is the off state, or it is in the bow state when it is in the air, head and tail. So, this is condition is the known as the superposition, means we are having a many possibility rather than one possibility, one at a time, like we the system in the state of 0 1 and in the both state. So, that is possible in the superposition. Another point is the entanglement. If we talk about the qubit, can be linked in a way that their states are correlated, means this entanglement, this quantum computing or quantum technology defined that there is a correlation between the bodies, means if one body is here and another in the space, so there is a relation between these two body. If it is moving here, then it is moving there also. So, the qubit can be linked in this way that their states are correlated even when physically separated. As we discussed, that one body is here and there is another, so this can be possible. In operation, so an operation on one entangled qubit instantaneously influenced with the other, enhancing computational power. So, that is the entanglement. There is a correlation between the body, not necessarily at the same, in the same reference, but in the different reference also. Another is the quantum interference. So, this is the process where the quantum state of the qubit affects the probability of collapsing to a specific outcome. When we use all these bits, then there must be a output that will be generated through the quantum inference. Now, another is a decoherence. Decoherence is the process in which the system in the quantum state collapses into a non-quantum state. It is very easy to understand that here we are having a possibility of 0, 1 and both. But here when we talk about the decoherence, the system will be in the 0 and 1. From the quantum state to the non-quantum state we will get. It can be intentionally triggered by meaning a quantum system or by other environmental factors. Sometimes these factors triggered it unintentionally. So, this system can take the once by using these technology, we can take the system from the one state to the another state, means from the quantum state to the non-quantum state. So, quantum computing requires avoiding and minimizing decoherence. Decoherence means where we use that for the different purposes. Now, this quantum bit, that is a very important part of the quantum technology. Then we will discuss that how it, what is this, what is the symbol of that, and how we will use it. So, since the quantum system evolve according to the linear equation, that is the Schrodinger equation, there we discuss, and the linear combinations of the solutions are also the solution which are having the state of the qubits in which it is in the 0 state, or it is in the 1 state, or it is in the superposition state, and also that describe the same state. So, journal form of the qubit state can be represented as A0 0 plus A1 1. So, so A1 or the alpha 1 and the alpha 0 are the complex numbers that specify the probability amplitude of the corresponding state. So, both alpha 0 and alpha 1 explain the probability amplitude of that particular state. Now, another is a alpha naught square gives the probability that one can find out the qubit in the off state, that is the 0, and A1 square gives the probability that one can find the qubit in the on state. You see here 1 means on state and 0 in the off state. So, normalizing condition, it will be the 0 square plus A1 square is equal to 1. It must be in the 1 state. That when we can define by the block sphere, you can easily see here how the wave function operate. So, here there is a ellipsoid in the circle, and how we define that it is in the 0 state or it in the 1 state. Outside it is in the 0 state z dash, then phi is having a theta and phi from the z axis to the phi and y. We are having a phi with the x axis. So, classical and quantum bit, what are the difference between these? Classically we have the two states 0 and 1, but here we are having a 0, 1 and any other state, that is linear combination of these two states. Now, it can be measured completely, but here can be measured partially with given probability that changed by the measurement. Moreover, in the classical bits, they are not changed by measurement, but they are changed by measurement in terms of the quantum bits. Classical bits can be copied and quantum bits cannot be copied. Classical bits can be erased, but it cannot be erased. So, what are the advantages of the qubits? There is enormous quantum power. Why we are using in the quantum computing or the quantum technology? Number 1, adding qubits increases storage exponentially, right, because we require the more storage as the data is growing day by day. So, we requirement of the storage purpose. So, adding the qubits increases the storage exponentially. Moreover, the quantum computer doubles the power with every added qubits. Its processor will be fast. Moreover, to double the power of the digital computer from 30 bits to the 64 bits, to double the power of the quantum computer from the 32 bits to the 33 qubits. So, can do the operation on all the superpositions like massive parallel computations are possible in this quantum computer. So, we can do the fast and parallel computation in this quantum technology by using the quantum computing. One math operation on 2 power n numbers encoded in the classical computer with the n bits require the 2 power n steps or parallel processor, but the same operation of the 2 power n numbers encode by n qubits taken in a one step. A 64-bit computer can perform manipulation on the 64-bit binary number at a time. A 64-qubit quantum computer operates in the space of 264 dimensions or roughly 16 10 to power 18 number to specify the state of the quantum system. So, this makes complex problem much easier to solve by the quantum technology. Now, how many types of qubits are? We will discuss the types of qubit. Generally, qubits are created by the manipulating and measuring the system that exhibit the quantum mechanical behavior such as superconducting circuit, photons, electrons, trap ions and the atoms. So, there are many different ways of making the qubits used in the quantum computing nowadays. So, with the some better suited for the different type of the task. So, a few of the more common types of the qubit that is used in the quantum technology is the superconducting qubit, that made from the superconducting material operating at extremely low temperature. So, these qubits are favored for their speed in performing computations and fine tuned controlled in the extremely low temperature environment. Another type of the qubit that work in the trapped ion qubit. The trapped ion particles can also be used as a qubit and are noted for the long coherence time and highly highly used in the highly fast measurement we can do by using it, but they are such slower than the superconducting qubits. And there is the quantum dot. Quantum dot are the small semiconductors that capture a single electron, and it use the qubit, offering the promising potential for the scalability and the compatibility with oxidizing semiconducting technology. Another is a photon. Thus, photons are individual light particles and they can be used as to make the qubits and send the quantum information across the long distances through the optical fiber cables. As we know that nowadays we use the optical fiber for the networking processes, so that we can send the signal, Wi-Fi signal from one place to the another. So, they are being used in the quantum communication and the quantum cryptography. So, up to now we have discussed the quantum technology and how we use these quantum technology further in the quantum computing and for the other purposes. We will discuss in the next lecture. Thank you very much.